Okay, perfect. Let's get started with this. All right, so what I did for my final project in Flight Sim is implemented a multi-vehicle flight simulation using object-oriented programming. So why object-oriented programming? It led for a module code structure and allowed me to add an arbitrary number of vehicles to my simulation. The original code was set up for just one vehicle, just one plane flying around and being simulated. But I was able to use the class structure that's easily implemented in Python to make my code scalable to an arbitrary number of objects, which in this case are aircraft and missiles. So the overview, or the base of the code, the backbone, is the addition and subtraction of objects from two arrays, the self.vehicles array and the self.projectiles array. So throughout this code, at any step, whether it's the integration step, if it's the collision detection step, any of these steps will iterate through these two arrays and check or operate on anything inside of them. So when the level starts, the self vehicles array is populated by the user vehicle and then a bunch of other drone vehicles. And as any of those vehicles get destroyed, they are removed from that array and are no longer operated upon. Same thing with the self projectiles. Anytime a projectile or one of the missiles is fired, the self projectiles array is appended, or those objects are removed from the array, depending on if they're being launched or when they're destroyed. So these two arrays become the backbone of the code structure, and that's made very nicely through Python. So I'm going to talk about a little bit about these objects, the user and drone vehicles and projectiles. So the user vehicle takes the joystick, or in this case an Xbox controller, input, and those inputs vary the control parameters, the delta epsilon, delta A, delta E, delta R, and tau, which are the elevator, deflections, aileron, rudder, and thrust. These things on the previous page, you might be able to see each of the objects carry their own attributes. So, for example, this first entry in the self vehicles array is the user vehicle. It carries with it its state vector y, a Boolean telling, or a Boolean saying whether it's flying or not, and then also the time of death, which is used as in the explosion animation. So that's where these are carried. This delta E, delta A, delta R, and tau. Those are all carried as attributes of the object user vehicle. Then these controls are given to the D state, or the state equations of the vehicle. Those are integrated, resulting in the current or the next state of the vehicle. And this process is repeated at every time step. For the user projectiles, these are also integrated forward in time. When they're created, they take the initial y vector from the vehicle, and that becomes their y vector, or their y array. So they inherit the UVW velocities, the rotation rates, the position, and the orientation from its parent vehicle. It also takes in the y array of the target that it's given. It uses both of these to in a kind of primitive targeting system that affects an effective elevator and rudder that the missiles have. It's assumed in these models that it's an all-flying tail. It basically has 4 fins that are all at right angles to each other. 2 of those fins are all-flying ailerons, or all-flying tails, and act as the elevators, excuse me. And the other 2 that are vertical act as an all-flying rudder. And it's also assumed that it's a thin cylindrical fuselage in the missile, and so that doesn't really contribute as much to it. And so it's basically controlled by taking its position and the position to the target and deflecting the elevator and rudder appropriately. The user projectile also takes into account a change in mass. It has a thrust profile, which is basically just a constant thrust for a set period of time, but because of that, it loses mass for that time, and then once the thrust is completed, it no longer has a thrust component in its equations of motion. And so again, it has so the projectile m dot, as well as the delta E and delta R, are fed into the state equations that result in the vehicle's state. So for the drone vehicle, the drone vehicles are not integrated forward in time. Its position is not found through integration. It is on a fixed path, and that's a helix that alternates between a positive and negative pitch. So the vehicle path parameters, which are its velocity, the initial time, its XYZ coordinates, and then its bank, pitch, and amplitude of oscillation. Those are all randomly generated by the level generator at the startup of each level. Because I guess I should explain, I made it so it's a leveled system where you go through and the user tries to shoot down all of the enemy drones and then continues to the next level. So at the beginning of each level, these are randomly generated. So it calculates the helix based on the bank and climb that's generated, and then starts that helix at the XYZ, but then also it has a time variant. So it doesn't have to start exactly at 0 or at the Z0 location. It can start slightly off, which is a way to randomize the heading of the initial heading of the drone. But then it will climb or sink until it hits its bottom or upper limit as defined by the amplitude A, which are deviations off of the Z0 value. So it'll climb up to that value, and once it hits the ceiling or the floor, it'll switch pitch direction and go the other direction, and it'll bounce back and forth to those values. That way it doesn't climb off to infinity or go into the ground. So for the drone projectiles, they are also on a fixed path. They follow a straight line, but this line is calculated based on where the drone believes the target aircraft or the user aircraft will be by the time the missile by the time the missile reaches the interception point. So it is given the target aircraft's current position and velocity, and it extrapolates that velocity forward in time. And so it's an iterative process because initially it says, okay, it will take this amount of time for the missile to travel R. Then it says, okay, well, when the plane travels R distance, when the missile travels R distance, the target plane will have moved U, V, and W times T in that direction. So then it'll say, okay, how long does it take it to travel R plus UVW times T? And so it iterates on that and converges to a value and says, okay, this is how long, or this is where I should aim for. So that being said, it will only hit the target if the target continues at the same UVW velocities. If there's any deviation in those velocities or heading or speed or those things, the missile will miss. So it adds a good element um, of chance. So there is a chance to dodge, but if you don't do any sort of evasive maneuvers, you will get hit. So these missiles are also simulated through the velocities are simulated using a linear equation, this VA times T plus VB, to account for some sort of acceleration due to thrust, though there is no actual thrust profile given. It's just given through this velocity equation. So the drone projectiles are set up to be fired when the target aircraft enters the field of view of the drone, which is described by, I think, a 90-degree cone angle, so mu of 90 degrees, and within a certain distance, which I think is like 75,000 feet, 7,500 feet. Anyways, it's some distance away, and so there's a cone that if the user aircraft flies in to that cone, missile will be fired. And there's also a time delay that there can only be a missile fired every 3 seconds or so. So in addition to, in order to make the game more expansive, for it to feel a little bit more real, I added an infinite ground component. So the initial simulation only had I think 20,000 by 20,000 foot square, so it was possible to fly off of that square. I made it so that there's actually 4 20,000 foot squares, as seen in this image. And so there's the main square that the user plane is directly over, and then 3 other squares. And these 3 other squares are positioned based on what quadrant of the main square the plane is on. So in this example, when the plane's in this quadrant, there are the 3 other squares are here, but once it transfers into this quadrant, all these 3 squares are rendered on this side of the main square instead. This is because there is a 10,000 foot draw length, I think that's the term. So if you're at the very center of this square, you can only see to the very edge of the square. You can't see beyond it. It doesn't render anything past there. So once you deviate off it into this quadrant, then you should be okay, because you'll still only be able. It's still only drawing that circle. And so when you're at this point, it only draws this area. So that way you can always see to the horizon, and the horizon's always coming. You can't fly off the edge of the earth, which makes the game a little bit more realistic, and also allows the drones to be a little bit farther apart. Makes it a little bit more fun. So there are 3 modes to this simulation or game. So there's a free flight mode. This has no drones. It's just the normal flight simulator. You're flying a Cessna around, and all the flight data is saved and plotted for you at the very end. So it's very useful for academic purposes, if you're curious to see how a plane reacts by itself. So this is the actual flight simulator part. But then there's 2 game modes. There's an easy game mode and a difficult game mode. The easy mode allows the user, or has the user, use the drone projectile class for its projectiles. So all the projectiles, drone and user alike, follow that line. Use the line iteration process to launch the projectiles. Obviously, it makes it a lot easier to hit the enemy drones. It's still a little bit, still makes it a little bit difficult, and the drones can still fire at you, but it's a lot easier than the alternative. And also, in these game modes, there's no flight data that's collected. All of it's deleted to allow for the memory to be used with the multiple objects, and so the game doesn't slow down. In the difficult mode, the user generates the actual user projectiles. This means you have to do all of the aiming by yourself. You have to lead your target aircraft. Like I said, there's a small amount of targeting with the user projectiles, but not nearly to the extent that the drone projectiles have. So it makes for a much more difficult game environment. Also, the collision radius is doubled in the difficult mode. That means that instead of a 15-foot radius in which there's you'll explode just a collision radius. If any missile passes within 15 feet of you or enemy aircraft, you'll explode within 15 feet. That radius is doubled to 30 feet to make it a little bit easier for the enemy drones to shoot you down. Gives them a little bit of an edge. Okay, perfect. So let's go ahead and give an example of it then. Where's my mouse? Perfect. Okay. So go ahead and start it up. All right, so here's the main menu. It has our two buttons that you can toggle with the keys on the keyboard. I need to make them so that they work with the joystick, but that's a different project. It also shows the high scores up here. I implemented the high scores a little bit late in the game, so they don't reflect the actual high scores, but they do update once you reach a new high score. They automatically are updating. So I thought that was kind of cool. Anyway, so I will go ahead and jump into the, I'll go ahead and show the free flight mode first. So we have our loading screen, little aircraft taking off. Takes a little bit to load. I've added a lot to to the simulation, so there's a lot to load there. So I guess another thing to note here is the leveling system. There's one enemy aircraft per number of levels. So in this case, level 0 corresponds to 0 enemy aircraft. So in this flight sim, or this flight, the free flight, I've chosen to start off with a 20-degree climb, 30-degree bank angle. And you can see it starts at trim. It's going there. You can see that it's our little Cessna flying around. It's pretty cool. We're over this field. Down in the bottom center, you can see that I've added a radar. So the red line points to north. It's a little compass. So the user plane is fixed and the world rotates around it and the thing. You can also see in the red, there's a number of enemy aircraft count. And in the blue, there's the number of missiles remaining. I have it set up so that you can have 3 missiles in the air at a time. So once one explodes, you get that missile back. But you can only have 3 in the air at a time. There's also a lot of data that's being shown on the sides in this mode that gives us a lot of information as to what we're doing. So yeah, we can fly around, see all our things. I have it so that there's a stall indicator in the way that the angle of attack or side slip, depending on what's stalling, changes red. It flashes red when you reach a stalling value. So here you can see the angle of attack stalled there. You can also see right there on the right-hand side, there was a flash of the normal force. So the G-forces also will change red if they reach a certain critical value, just as an indicator that, whoa, you're doing some crazy stuff. So let's see, there we go. Pulling 10 Gs, I'm doing this backflip. So that's pretty intense. But anyways, so, I mean, G-wise, that's a lot of Gs. So that's the free flight mode. To exit out, you self-destruct. Makes it kind of cool. So in the other modes, and you can see, one second, let me pull these plots over to the other monitor. So you can see here's a 3-dimensional plot of where we traveled. Came up here, flew around, can see our loop-de-loop, and then we exploded there at the end. And there's also a plot of the 3D plot again, but then also a breakdown of the distances, two-dimensional projections of the 3D plot, and then our velocities and our alpha beta plots. So let's see. So if for some reason when I converted it over to my Mac, it won't let me go back to the main menu exiting from free flight mode. So we'll just start it up again. Okay, so this time we'll jump over into game mode. There's easy and difficult. We'll jump into easy first. So this is level 1, so we have one enemy drone. And level 1's a training level, so the drone doesn't actually fly. It sits there a fixed distance and just rotates around. Makes it so you can get your bearings, feel the flying, check out the targeting system. Yeah, but it makes it really easy in easy mode because since it's not moving, its UV and velocities are constant, so you pretty much are guaranteed to hit it unless numerical round-off error gets in your way. So there it is in front of you. So to shoot a plane, you have to target it. So now you can see it's targeted. If the targeting circle is that orangey color, it means it's in range in your cone field of view, but it turns blue when you are outside, when it is outside your field of view, that cone that's in front of you. Also, the cone for the user is much more limited. It's only a 10-degree cone angle instead of a 90-degree cone angle, and it's limited to, I think, 2,500 feet. So you can see it's blue there, but when I turn around, bam, it's orange and I can fire. So you can see it blow up. So if you run into the orange, the explosions, you can blow up yourself. It's just kind of a fun thing. You need to pay attention to if you're firing really close in front of you. So another thing with the radar, you can notice there's the little spot that represents the enemy aircraft. If it's blue, that means the aircraft is towards the sky or above you. And if it's a brownish color, it means it's below you. So it gives you a little bit of that third dimension there. So you can see here up and to the ahead and to the right of me, there's one aircraft that's above me and one that's below me in altitude. I can move over and you see I've targeted the one, but I can toggle and target the other. So I can toggle between which one I want to target. As you notice, we're flying over the ocean now. There's actually 4 randomly selected maps in game mode. The fields, saw that it just shot at me, and the radar turns red when there's an enemy missile in the air. So you got to watch out for those. But yeah, so there's the field, the ocean, the moon, and Mars. It just kind of makes it a little bit fun, I think. So anyways, so let's see. So we're going down. There's that guy. Let's see if we can go take him out. And fire. Bam, nailed him. And you can see that, so there's 2. I don't know if you saw that in the bottom. The count went from 2 to 3 after the missile was, so there it's 2, and then 1. But then it goes back up to 2, and then we beat the level before we could see it go back up to 3. So we'll see, maybe we'll, yeah, we'll go ahead and see ourselves get hit. I'll see if I can convince one of the drones to hit me, and then in this level, and then I'll show you the difficult mode. Okay, let's see. They're kind of far away, so I'm going to go ahead and just dive into the ground. Oh, and this way we're also in F-86 Sabre in this level. Okay, so that's what I was able to get. So now I was able to get back to the game mode. So we'll show difficult. I'll just show the first level on this. So it's the static target, but I'll show how the missiles have to be aimed by the user. And then I think that pretty well covers everything. I mean, you've seen, I think on the last level, you might have seen the seam in the ocean where the one field the one Earth panel was, and the next one ended. And so that shows what the infinite Earth type thing. Okay, so I targeted my thing, but if I aim down below it, you can see that the missile follows a more parabolic trajectory. So I have to aim above the, so I can fly through the edge of it. I just can't get too close inside. So you have to aim. You have to lead it yourself. You can't just fire willy-nilly and expect the missiles to go towards the target you're wanting to. Like I said, it does a little bit. It accounts for a little bit of error in there that makes it nice. It smooths out the firing experience, but other than that, it doesn't help you out nearly as much. Okay, so here's the Mars landscape. So we can see that there's this guy over here. Let's go see if we can't. So in this mode, so in difficult mode, I can fire the missiles at any point. There's no cone. It'll always fire just in front of me. But really, I mean, you're not going to hit them if you're this far out. Well, you can see that they take off and they move in a certain direction. Sometimes they have a really high angle of attack and whatnot. But yeah, so now that we're closer, we can fire out and lead them. But yeah, it makes for a lot longer of gameplay. There we go, got him. I don't know if you saw that the missile exploded a lot farther out from the drone than in the easy mode, but that also helps out with the difficulty of aiming yourself. Well, anyways, we'll go ahead and self-destruct here and call that a day. I appreciate you watching the video and showing interest in what we've done.